Hey there, AP Pre-Calc. It's Miss Adams from Flamingo Math. In Lesson 4.8, we have 3 days of looking at vectors. When we study mathematics and science, we often see quantities that are described completely by their magnitude. Those numbers are called scalars, like volume, distance, time, and temperature. There's times when we need more information like velocity or force, and since those elements have both magnitude and direction, these concepts can be expressed by using a directed line segment, and we call those vectors. We like to use arrow notation to represent a vector like PQ here. Similar to array, a geometric representation of a vector has an initial point called a tail and a terminal point called a head. We name vectors by using a bold lowercase letter such as U or V. But on paper, it's difficult to write those in bold. That's why we like to use the arrow notation. Let's look at this first example. We're given an initial point at the origin and a terminal point AB. A vector in standard position can be represented as vector AB, where we're using these brackets that are little brackets like that. That's called component form. So let's first of all sketch the point P 4, 1, and then the point Q 7, 5. So point P is located at 4, 1. This is P. And point Q is located at 7, 5. This is point Q. That's our vector. It has direction and magnitude, and we want to sketch V, which is located at 3, 4. 3, 4. So this is vector V. So how can we describe the relationship between those two vectors? Well, I would say the vector PQ is equal to the vector V because if we did 7 minus 4 and 5 minus 1, we would move that vector PQ back to the origin at 3, 4. The magnitude of vector V is 5. The vectors are equal. They're going in the same direction and having the same magnitude. Point Q was 7, 5, and point P was 4, 1. And point Q, vector V had a terminal point at 3, 4. The vectors are equal. PQ is parallel to vector V. They have the same direction and magnitude. Let's talk about magnitude here. The magnitude or norm of a vector is given as component form. You can see component form. How do we find magnitude? It's the same as finding the hypotenuse on a right triangle. If vector V is represented by the arrow from xy to the second xy, then the magnitude can be found using the distance formula. And we also know the notation if we're given component form, vector V can be used with the Pythagorean theorem. Let's sketch and find the magnitude of vector V that terminates at -2, +3. That's the terminal or tail. And we know this is vector V. That's a little arrowhead there. You can see the direction and the height. So 2 here. Our magnitude of vector V is a squared plus b squared. So the magnitude is -2 squared plus 3 squared. That's 4 plus 9. The magnitude is the square root of 13. So magnitude of vector V is radical 13. Component form of the vector is given by finding the difference between the x terms and then the difference between the y terms. That gives us the AB terminal point. So let's give this one a try. We've got component form given by point P is located at 3, -2. This is point P, and Q is located at 7, 5, point Q. We've got a vector going that way, and we want to find component form by taking it back to the origin. So we can do that quite simply. Whoop, that's a Q. We can do that by finding vector V is the same as vector PQ, 7 minus 3, so the x coordinates, difference of those, and the difference of the y coordinates, 5 minus negative 2. So vector V can be represented in component form as 4, 7. Find the magnitude of the vector, so we could go draw that over here. 4, 7. 4, 7 is vector V. It's got the same magnitude and same direction as vector PQ. The magnitude of the vector, magnitude of vector V, is the square root of 4 squared plus 7 squared. Our magnitude of vector V is the square root of 65. Now, for vectors that are represented geometrically in the plane, the components of the vector can also be found using trigonometry. Notice how the magnitude of the vector is the length of the hypotenuse of a right triangle, or in polar form as the radius r. We want to find component form of a vector whose magnitude is 8 and is in the direction of 1 square root of 3. So first let's get some vocabulary going here. It's these 3 important facts that we're going to incorporate using information from trigonometry. So if x is the a value and y is the b value, then the magnitude is the length of the hypotenuse. And our task, we know the magnitude is 8, so that's our hypotenuse here. And it's in the direction of 1 square root of 3. So how do we find the angle? So the angle is tan inverse of radical 3 divided by 1. So that puts our angle at pi over 3. And we know that the point 1, 3, 1 radical 3, is located in quadrant 1. So our angle is good, pi over 3. Our magnitude is 8. And we're going to use the formula A is magnitude. So I'm going to erase this. Magnitude is 8 and the cosine is pi over 3. So magnitude 8 and cosine pi over 3. So 8 times a half, our A value is 4 because cosine of pi over 3 is a half. And then doing the same thing for the B value, we have cosine, we have sine, so the magnitude is 8. Magnitude is 8, and the sine of pi over 3 is radical 3 over 2. So 8 times radical 3 over 2 is 4 times the square root of 3. That means our vector V, it can be written in component form. That's what they asked us to do, component form, as 4, comma, 4 square roots of 3. This is vector V. A goes, X goes out 4, and Y goes up, keeps going back to the highlighter, 4, and Y goes up 4 square roots of 3. And we just got longer out there. So 4 and 4 square roots of 3 is representing a vector whose magnitude is 8 in the same direction as W. That's day 1. This was fast. See you tomorrow for part 2.